Okay, so give me an example.
So like the average of like the same area.
Okay,
So like basketball players,
okay.
players, how they
So what-
average touchdowns or
Mm-hmm. Okay, so their performance.
yeah.
Okay, what else? When we think of averages.
I would say middle of the pack, like not exceptional, not terrible, but right there at the middle.
Okay,
The class that most people would fit in.
okay, so you're talking in terms of just general population, maybe?
Yeah.
Okay. What else?
Isn't it all the variables divided by how many variables there is, or is that a
Very good. Yeah, so that's a calculation. That's a measure of central tendency. Yeah, you have. If let's say we just did our exam, right? So if I wanted to find out what the average score was, I can take all the scores and then divide by the number of students who took the exam, right? Which would give us an average score. Yeah, very good. Anything else comes to mind with average? What about the most common occurrence? Trying to think of an example. Maybe kind of like what you talked about, you know, the average person who's maybe not exceptionally at the top or not at the bottom, but somewhere in the middle. There are actually 4 different ways of calculating average. And some examples I'd like us to look at. Of course, we've got our little box here. How long are you delayed by road congestion? So they're saying no matter where you live, one time or another, you have been stuck in traffic. Especially, I don't know if you run into that if you're commuting from Denver, how that looks like. I know, and I guess I always tell this story, I rarely ever get on I-25 because no matter what time of the day it is, you're gonna be stuck, right? Behind some pretty bad traffic. I-70, if you're trying to go to the mountains over the weekends, you're gonna have really bad traffic congestion. If you're living in a small town, you're probably not gonna see quite as much as you would like if you're going to a place like Denver or Colorado Springs, maybe. So they're saying to see whether there are more traffic delays in some cities than in others. Statisticians make comparisons using descriptive statistics. So this is a statistical study by the Texas Transportation Institute that a driver is delayed by road congestion an average of 36 hours per year. 36 hours per year. So, I mean, that seems like a pretty, I don't know, does that seem a lot of hours? Or does that seem not enough for a year? How would you look at it?
That seems kind of low because that's like 40 minutes a week.
40 minutes a week, okay. Doesn't seem that much. I don't know, 36 hours to me seems quite a bit, but then again, I try to avoid big city traffic as much as I can. So, you know, if I'm stuck 20 minutes in traffic, I'm like, God, my life is over, you know, there's nothing left for me to do now. So I'm a terrible person when I'm behind the wheel. So yeah, don't get stuck behind me. I'm not nice. All right, so let's look at some examples in terms of when we talk about averages. So I've included some from your textbook here. So this is from the American Averages book by Mike Feinsilver, I guess, and William Mead. The average American man is 5 feet 9 inches tall. The average woman is 5 feet 3.6 inches. Does that sound about reasonable, or were you expecting a different value? Does it?
I mean,
Seems pretty normal. 5 feet 9 inches for men and 5 feet 3.6 inches. Well, thank you for the 0.6 inches. I'm at 5'3", so it makes me feel really average. The average American is sick in bed 7 days a year, missing 5 days of work. On the average day, 24 million people receive animal bites. Okay, so there are actually 2 different examples there. Average American is sick in bed 7 days a year, missing 5 days of work. Alicia, you don't seem to agree with that.
Yeah, I mean, there's 365 days in a year, 7 days missing. Not that bad.
Not that bad.
Pretty good attendance.
I feel like it all depends on like your job.
Yeah.
Cause I work with 2-year-olds,
Okay.
so I'm sick all the time.
Well, definitely, because whatever they're bringing,
Yeah.
you're probably getting that. I can kind of see that.
When I go to the server and almost at least once a week, one server has to not be there.
Not be there
At
because
least
they're out
once a
sick.
week.
Yeah. And then, if you work, I don't know about Colorado, but my experience is from Kentucky, and we had students who were working in factories. They have literally zero tolerance policy. So if you're going to call in sick, basically don't come back to work, which seems really harsh to me. But a lot of these factories literally have this policy. So I can't see somebody in that profession missing 5 days of work, right? Because they're not going to let that happen. I mean, these guys had to leave class early so they could make it to their whatever time they had to be there, because even if you are 2 minutes late, you're gone. So some places are really, really strict about how they deal with that. They said on an average day 24 million people receive animal bites.
I think
You think it's true?
I think it's curious. It's, everything going on with the pit bull ban. I think Denver Post just put in yesterday that like across Denver, there were just over 500 dog bites as a whole. And what they're trying to do, they're trying to create an argument for justify that the pit bull ban should be repealed because it was like 20 bites for pit bulls and like a lot of small dogs. But that's like over the whole of the major Denver metro area, like over the whole country, 24 million. That seems excessive.
That seems excessive.
Yeah.
Well, like they're probably not talking about like the cat bites me because I'm not giving him enough attention. I don't obviously have to go get that checked out. So
Well, and and this is kind of getting a little bit into that ambiguous, because when you say animal bites, well, what animals are we talking about? Are we talking about dogs and cats? Are we talking about, I don't know, critters?
but that's
Kids
like
trying to hit a horse, and then I don't know what happened next, but the horse trying to bite the kid's
Oh.
head, and then there's like getting.
Okay, no, I have not seen that. However, I have seen a lot of posts by Colorado Parks and Wildlife where, when the rut is happening in Estes Park, people are actually walking up to these elks and
Oh,
trying
yeah.
to pet them. And I'm like, really? Really? I mean, all common sense has obviously gone out the door because these are wild creatures. There was this, I think it was on the news the other day, this lady invited this, I don't know if it was a deer or an elk, I didn't pay that much attention, with bread to get this creature into their house with bread and feed it. You cannot feed wild animals because you change their behavior. So, I would say out of those 24 million people, 23 are probably doing something dumb to get bit by animals, but that's just my opinion. And let's see, the last one here is on his or her 70th birthday, the average American will have eaten 14 steers, 1,050 chickens, 3.5 lambs, and 25.2 hogs. Well, that's obviously assuming you're a meat eater, right? I mean, if you're not a meat eater, I guess you're doing 0 of those. Just from your experience, do you think you will have eaten that many animals by the time you're 70?
Yeah.
Least, maybe a little bit more. All righty. But here's the idea. When they say average, well, what calculation they're using? Because remember, I told you there's 4 different ways of calculating an average. So one of them was what Alicia said, you take the total quantity of items you have. So if we're talking about how many steers a person has eaten, you'd probably, I guess, calculate how much meat they've eaten and then divide by the total.
How do you find that out though? Like,
Um,
no one counts their meat.
I think it's an idea of you take, again, we get back into that whole sampling idea, right? You take a sample And you're probably seeing over a period of, I don't know, maybe so many years, how many times they're eating what kind of meat. I mean, you're not eating the whole animal if you really think about it. I mean, are you really going from, what do they call it? Nose to tail or
Rooted to the tuta?
no? What's that?
The rooted to the tuta?
The ruta to the tuta?
Yeah.
I'm not sure I've heard that before. Okay, I love that. So the idea is very few people are probably eating all different parts of the animal, right? You're probably eating a certain cut most of the time, but I would imagine that they've just probably taken the sample to see if you're eating, so many ounces of meat a day, then over so many days, how much does that add up to? Compare that probably to the weight of a steer, and then you're probably saying, okay, if the steer weighs, whatever, how much does a steer weigh? A male cow, I guess.
They're like between like 800 to
100,
yeah.
1,500.
Do they get to a ton?
Yeah.
Can steers get to a ton, which would be
Yeah.
2,000 pounds? Obviously, you can tell I'm not a farm person here, so. But I would imagine that's kind of what they're going with. If you've eaten 2,000 pounds of meat, then that's how many steers, I guess, you've eaten or whatever. So, obviously, we are kind of getting a little bit away from being a meat-eating society. For most part, we still are, but we are seeing more and more trends with non-meat eaters. Maybe not as big part of a population, but it's more than what you would imagine even 10 years ago. You are seeing that, and the evidence is in, look at all the different types of restaurants you now have available. I am not a vegetarian, but I try to be as much vegetarian as I can. And just from my experience, I can tell you Colorado has more vegetarian friendly restaurants than they were on the East Coast. So California, Colorado, for that matter, even New York, some of these states are more friendly towards people like me than, let's say, places like Kentucky, which is definitely a meat-eating culture there. Okay, so the 4 different measures of central tendency we are going to be looking at is mean, which is what Alicia was talking about. We're going to talk about median, which is kind of what Michael was talking about, which is the centermost position. So not towards the top half, not towards the bottom half, but right there in the middle. You've got mode, which is what I was talking about in terms of the most common occurrence. And then you have mid-range. Mid-range literally means, think about the word range that we looked at when we were doing our frequency distribution. So mid-range, the calculation's a little bit different. You take your highest data value, you take your lowest data value, add them together and divide by 2. So you basically just take the average of your highest and lowest value, and whatever that number comes out to be ends up being your mid-range. And then the idea is, what kind of average are we looking for? What calculation are we looking for? And which one would make more sense? Does it help to do a mean as opposed to a median or a mode, mid-range? So 4 different calculations that we'll be looking at. And again, obviously, as I tell you all the time, I would prefer you guys to read the textbook instead of me having to read through all of this. So I'm actually going to skip over some of this. They're telling us here that if you are a store owner, then the average size of a man's shoe is size 10. So does that mean he's only going to carry size 10 shoes? Well, no, because he's going to have all different types of sizes coming up, right? So they're not all the people who shop at the store are going to be this average shoe size. So of course you have to take into consideration people who are going to be smaller or larger than that shoe size. So, just calculating the average is not enough. Just looking at that central tendency is not enough. Sometimes we actually also have to see how our data is dispersed or how spread out that data is. So that's where the measures of dispersion come into play. And for measures of dispersion, we'll be looking at range, standard deviation, and of course, we'll be looking at variance as part of that calculation. So 4 measurements for a measure of central tendency or average. For dispersion, you'll be looking at 3 different calculations. And then we will actually also look at measures of position. So you may have heard about percentiles, right? When we do those standardized testings, SATs, ACTs, they're always asking, what percentile did you place into? So percentile is a calculation for position, but we will actually also be looking at deciles and quartiles. So we'll be looking at different measures of position as well. And so a lot of different calculations that we will be getting into. And then the very last part that we're going to actually talk about is the exploratory data analysis, which is where we're going to get into our box plots and 5-number summary. So let's start out with our measures of central tendency here first. So just as a definition, so remember how we had talked about when we take a sample size as opposed to talking about the population. So depending on which of the two data values we're looking at, if you're looking at your sample, we call it a statistic. So we're saying statistic is a characteristic or measure obtained by using your data values from a sample. If you're using a population, then we call it a parameter. So just depending on, are you looking at a sample size or are you looking at the entire population here? Now, again, we have our rounding rules here. So basically, and I don't know if you guys have heard this in some of your other math classes before, but we always wait for the very last step to do our rounding. So we never try to round in the intermediate steps. So if you are doing, especially when we do calculations for standard deviation, you have to be very, very careful. So don't round any of those numbers that you would be working with, through the process. Once you get to that very final answer, that's when we round. So they are asking you to not do any rounding until you're getting to that final answer. So that's something you want to keep in mind. Because what happens is if you start rounding them in the intermediate steps, the final answer is not going to be accurate. It's already going to be pre-rounded off, and you're not going to get the right answer. So again, depending on are you using sample or population, you are actually going to have two different notations for your mean. Now, mean is the calculation where you add all your data values and divide it by the total number of values you have. So if you're using a sample, you're going to have X with a bar on it, right? So X bar. If you are looking at the entire population, we actually use Greek letters for that, which is going to be mu, the symbol for your mean. So you really have to be careful about when you are working through your examples, your problems. Well, am I looking at a sample? Do I need to use X bar for my mean? Or am I looking at the entire population and do I need to have mu for my mean? So just kind of keep that in mind. For your rounding rule for the means, they are telling us the mean should be rounded one more decimal place than your raw data, okay? So kind of like we had for our boundaries in the same way, but these guys are not always going to end in a 5. So whatever your raw data is, one more decimal place. So if your raw data is whole number, then your mean will have one decimal place. If your raw data already had a decimal place, you're going to have 2 decimal places in your mean. So just looking through our example here, this one is talking about the number of confirmed flu cases over a 9-year period. So this is our raw data. You can see these are whole numbers, which means our mean will have 1 decimal place. So literally you're just taking all those, adding them together, dividing by your n, which in this case, this was a 9-year period. So that n is 9, right? Divide that and round your answer, and you've got 64.2. So we're saying on an average, the mean number was 64.2 confirmed flu cases. Talking about system-wide sales for US franchise for a well-known donut store over a 5-year period. So we've got our total sales in millions. And well, since they're telling us it's Krispy Kreme, I'd imagine that's the donut store we're talking about here. So you take those 5 data values and of course you're dividing it by 5. Again, whole numbers in the raw data, 1 decimal place in your mean. So let's pick one example out of our textbook here. Okay. Let's do the very first example that we have up here. Okay, roller coaster speeds. So this one is telling us the height in feet of 14 roller coaster. So let's start by finding out the mean for this data. And what will that come out to be? Okay, let me see if I can. Okay, so what will this come out to be? And first of all, is this going to be a sample or is this going to be a population? It is going to be a sample since we're only looking at 14 roller coasters here. That means you're going to be using X bar for your mean. And what did that number come out to be? Sorry? 104.1? Of course, you're taking all these data values, and for the mean, you don't have to worry about putting these in order, since you're just adding all those numbers up. And they're telling us we have 14 roller coasters here, but it's never a bad idea to make sure you're getting that same number. Do you have, what was the grand total for just the, sorry, that should be 14. 1,457. 57, and then we're dividing this by 14. Okay, and approximately 104.1. Okay, and this was height in feet. Okay. If you are doing 1457 divided by 14, yeah, you're getting your raw answer as 104.07, which will round up to 0.1. Everybody okay? Okay? So the only thing you really got to be careful about is don't skip a number and don't mistype a number, because those are honestly the only things I have seen where mistakes happen on this. It's just being in a rush and trying to get it done too fast. Okay. Okay, now in terms of grouped data, how would we go about finding the mean for that? So we are saying that we are making the assumption that the mean of all the raw data values in each class is basically going to equal the midpoint for that class, right? For that particular grouping. Now, even though this will not always be true, because we have seen when we were doing our frequency distributions, you never have even number of values in all the data items, right? So that's not necessary that your mean for each group is going to be the midpoint, but the idea is it will still be approximately somewhere too close to that midpoint. So that's what you do for group data is you need to calculate your midpoint, and then we're actually going to need the frequency for those group values to be able to calculate our mean for a group data. So just going through these steps, find the midpoints. You're going to take the midpoint multiplied by the frequency for that group, and then basically you take the total of that product that you end up with when you multiply your midpoint and your frequency. So right here, this is basically the summation symbol, which is of course again a Greek letter, but basically we are saying take your midpoint, which is the x sub m, multiply it with the frequency of that group, and then add all of these products that you're going to have. So the summation is going to be for all the products. And then of course, you're still dividing by n. Now remember, for grouped data values, your n is the total of your frequency column, not how many groups we have, or classes as we were calling them. So not how many classes you have, but what is the total of the frequency column. That's going to be the n value, your total. So looking at this example here, we're talking about salaries of CEOs. So we're going from, looks like using class boundaries, we're going from 15.5 million all the way to 40.5 million, right, in our classes. So you've got your frequencies for each of those. Adding the frequency column, we have a total of 25. So that 25 is our n. We calculate our midpoint. And of course, you know, for the midpoints, you take the highest data value, add it with the lowest one, and divide by 2, right? Get your midpoint. Multiply that with the frequency. So 13 times 18, 234, so on and so forth. And then this is where we add up this column to get our numerator, which is the 555, and then take the total of the frequency column, which is 25, and divide those two numbers to come up with your mean for grouped data. And of course, you can see same rounding rules. If your raw data is whole numbers, mean will have one decimal place, and you end up with 22.2 million as your answer. We'll get to that in a minute here. Let's find us an example for grouped data. Okay, right here. We are looking at wind speeds for a sample of 40 states. So here, we're going from 47.5 all the way to 96.5, and then they've got the frequency, which is how many states had that maximum wind speed. So in this case, if we are talking about finding our midpoints first, okay, let me see if I can get these to be side by side. Okay. No, it's not gonna happen. Alrighty, go ahead, calculate your midpoints, and then I'll switch over to my screen. So it looks like we have 7 classes. You should have 7 midpoints. And then, of course, to find our n value, we will also need to add the frequency column and see how many total items we have. So what are those midpoints? Kimberly, what did you have the midpoint for the first class?
51.
51, very good. 58, very good. Third one, 65. So basically it looks like what, increment of 7? Yeah. So what should the next one be?
72,
Very good.
79,
79,
86,
86,
90.
93. All right, very good. Did we add up the frequency column? 43? 33? Okay. So we've got 13, 15, 20, 29, 37, 40. Yeah, 40. So it looks like you've missed something in there if you're only at 33. Okay. Finding our midpoints. Everybody did that? We got our total for frequency, which they were telling us it's a sample of 40 states. So your frequency should add up to 40. And again, like I said, it's always good to verify, then just go with what they're telling you. All right, so your next part is, of course, finding the numerator to calculate our mean, which means you're going to take your midpoint and multiply it with the frequency. So you're going to be doing 51 multiplied by 3, 58 times 2, 65 times 9, 72 multiplied with 13, 79 and 8, 86 and 3, 93 and 2. Okay, so 51 times 3. Say that one more time. 116. Divided by, okay. 936. 632. Okay. 258.
And 186.
186. Very good. And do you have your total?
Yeah, 2,860.
2,866. Alrighty, can anybody else verify that total for me?
Yes.
Okay, so, okay, I'm not sure it's gonna. Okay. There we go. This is gonna be very interesting. Okay, so if I'm trying to find my mean, and again, this is a sample of 40 states, right? So we're not looking at the entire population again. Your summation for frequency times the midpoint is coming out to be 2,866. Our total data values were 40, that's our N. So what does that number come out to be? 71.65, and then using our rounding rules, what will that become?
71.7.
Very good, 1 decimal place more than your raw data. And since these are class boundaries, right? We know the class limits would be whole numbers, which means your wind speeds are also going to be whole numbers. So that's why your mean is going to have 1 decimal place more than the raw data. Or in this case, I guess the same number of decimal places as your class boundary. Okay? Questions? All right, let me see if this guy lets me save this image. Okay. Okay, so here they're talking about the histogram showing you the 50 wealthiest individuals. According to the Forbes magazine, they're saying the mean age is 66 years, the median age is 68 years, and they're saying explain why these two statistics are not enough to adequately describe the data. So looks like we're going from the youngest person in this category being somewhere about 34 and a half years to 94.5. They're telling us the mean age is 68, 66, and the median is 68, and why this is not adequate to describe this data. What do you think? Why would those numbers not be adequate? 66 for a mean and 68 for a median?
Because of the sample size and how many people there are.
Yeah, so they're telling us this is 50 wealthiest people. So that's a total of 50 that we have, based on those classes. So not really because of that reason. What are you noticing when you look at the histogram? Where is your data concentrated at?
4.5.
Yeah, because those are your 3, tallest bars, right? Going from 54 and a half to 84 and a half, you can see there are 6 people in this age group, right? 34 to 44, you've got 4 people in the second one, and you've only got again 4 people in that upper age group of 84.5 to 94.5. So since your concentration is right here, mean is probably not going to be a great measurement, because remember, again, we just did our mean calculations. What do we do with mean? We take all the data values, add them together, and then divide by the total, right? Which means we're taking this lower end ages in there also, and we're taking these upper end also, which is of course going to spread your data out a little bit more, because now you're including these smaller values. But if you look at it, we're probably going to be somewhere in this data values here, where you're going to see the maximum of your people. So in this example, you could actually also use mode as part of an average calculation, because you can see this is my tallest age group here, which is going to be from 64 to 74 and a half, and that looks like about 13 people in there. So your mode would be the most frequently occurring age group in this case. So maybe that would be a better calculation in this, because that's taking into consideration what the frequency of those ages is, as opposed to taking everybody and finding a mean calculation based on that. So your median calculation is basically as the name suggests. And you know, the easiest way to think about a median is think about the median on a highway, right? What does it do? It basically cuts the highway into two parts. You have your 2 or 3 lanes, whatever you have on your highway on that side, and 2 or 3 lanes on the side you're driving on, and then median is going to cut it halfway through. So that's exactly the calculation that happens with the median. You are trying to find the centermost point of your data values. So for a median calculation, you do have to arrange your data values from the smallest to the largest, and then you have to find that centermost position. So in this case, they're talking about the median income for college professors was reported to be about $43,250. And they're saying this measure means that 1/2 of the professors earned more than $43,250, and 1/2 of the professors would have earned less than $43,250. So again, that's that right in the center, what that value would be. That's your halfway point. So make sure you are arranging your data in order. That's what they're calling it, as a data array, and then find the midpoint, the centermost point for that. Now, this is the part we have to be careful about, because depending on, do you have even number of data values or odd number of data values, that median position is going to change. So if you have odd number of data values, you are only going to find one single number in the center of your data, right? When you arrange it from smallest to largest. But if you have even, so let's say you have 10 data values, you're looking at 10 different professors' salaries, let's say, then that means you're actually going to end up with 2 numbers that are going to fall in the center of your data, which means we end up taking an average for those 2 center values. So here they're telling you, if you end up with an odd n value, how many data items you have, select the middle data value and you're done. If your n is even, the mean is going to, you take the mean of the 2 middle values, which means add them and divide by 2. So you can look at these next couple examples here. We've got 5-year period for the number of tablet sales in millions. So you can see we have 17.6 million as the smallest value. Arranging it in order, we go 69.8, 108.2, 159.8, and 222.6. So this is crucial. Please remember to arrange your data value. And then you can see my centermost position is going to be the 108.2 millions of units that were sold. So as far as the median calculation goes, you're looking at 2 spaces here, or 2 values here, 2 values here, right in the middle. There's actually a position formula that you can actually use here. So if you are just wanting to know in what position that median is going to be, your little position formula is n+1 divided by 2. So if you have 5 data values, which is what we have in this case, 5 + 1 is 6. 6 divided by 2 is 3, which means in the 3rd position, you are going to find your median. And you can actually count from either end. You can go 1, 2, 3 from the right and still get to the 3rd position, or you can count from the left and still get to the 3rd position. So that position formula actually really helps you out. If you ended up getting something with an even, I'll show you how that position formula works out in that case. So here, with our next example, we've got tornadoes. So the number of tornadoes that have occurred in the US over an 8-year period. So again, we want to put these guys in order. We've got 8 data items there. Again, you can verify that. So when you put it in order, this is what you end up getting here, right? Now we're talking about the position formula. So that's n+1, which in this case would be 8 + 1 divided by 2. And what is 9 divided by 2? Yeah, 4.5, 4.5, which means your median is going to be in the 4th and the 5th place, right? Because 4 and 4.5 will be between 4 and 5. So if you look at the 4th and the 5th place, again, starting from the left, that's 1, 2, 3, 4, and 5. So these two numbers. If you start from the right, 1, 2, 3, 4, and 5. Again, so that means you're going to have to take an average of 764 and 856. And that average, as you can see, comes out to be 810. Okay, so the position formula really helps you out, especially if you have a large data group, right? Like 40 items, 50 items, whatever that number might be. So we had looked at that number 1 example. Let's go back to that and calculate our median for this example. So the first part, of course, would be arranging this in order, getting our data array. So median, we use MD as our abbreviation for that. So going in order, where would we start? 50, and there's 2 of them, right? Okay. So we got our 50s. What would be the next value? 84. Okay, then 91, very good. Before that, there's 2 of them, yeah, 95. Okay. Okay, and how many of those are there? 2 of 102s. I'm seeing a 105. 118. 120. 125. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, there's 2 of those. Okay. So that should give us our 14 items, right? And they told us this were 14 roller coasters in this example. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So using the position formula, where will our median fall? Yeah, because you're going to look at 15 divided by 2, which will be 7.5. So that puts us with what 2 numbers? Because the position is going to be the 7th and the 8th position, right? Between both the 102s. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, very good. Which of course that means your median is going to be, yeah, because even if you did the whole calculation, which is 102 plus 102 divided by 2, you're taking the average of the same number, you're going to end up at the same number, 102. Yes.
The median doesn't account for drastically different values.
You talking in terms of outliers?
Yeah, so if you have if your numbers are 1, 2, 3, 4, and 12 billion.
Yeah. Then you're ignoring the 12
Then you're
billion.
ignoring the 12 billion because like your mean or your median, excuse me, is 3.
Right. Because you're going to be looking at the position,
Yeah.
right? Not in terms of, now if you did that average, average doesn't say anything. If you did the mean, then you know that 12 billion is, I think what you said, would be pulling your mean towards more closer to it, right? But that wouldn't be really an accurate number, because if 3 of your numbers are concentrated in that 1, 2, 3, 4 area, then 12 billion obviously is changing your math completely.
Yeah.
So in that case, a median may be a better calculation as opposed to that 12 billion, because that number is throwing everything off. And you know, a lot of times, and I think we'll see an example here where, you know, if you look at income brackets, then a lot of times that happens if you're including somebody who's on that, you know, upper maybe 6-7 figure salary, but then you have all these others maybe with a 5-figure salary, then of course that same thing's going to happen, right? That higher number is going to try and pull your mean towards them. Whereas it may be better to kind of see, you know, like we're talking about that average salary of the professors. So in that case, if you bring in maybe somebody who's teaching at private institutions, because typically private institutions will pay you higher than a public institution will. So if you bring those calculations in, then again, same thing's going to happen. It's going to bring that average or that mean to a higher point. So a lot of times that is something you have to consider, and we'll talk about it a little bit. As researchers, as statisticians, you have to make that choice of, do I want to bring this larger number in? Is it relevant to my study, to my data, or leaving it out is going to be okay, and I'm not going to bias my data, you know? So sometimes we have to make that decision of, do we need to include this number, or is it throwing everything completely off? Okay. Now, your book really doesn't ask you to do this, but I want to show it to you so you're aware of how to calculate. When we talk about grouped data, and that was number 13 that we had looked at, how do we calculate the median in terms of a group's data? Okay, so we know this one has a total of 40 states, right? So using that position formula, which position should our median fall into? So let's go back. No, not you. Okay. So n plus 1 in this case was 40 plus 1. And what does that come out to be? 20.5, which means your position is going to be between the 20th and 21st, right? So the way you actually calculate the median for this is you actually start adding your frequency column till you hit that 20 and 21 value. So let's say if we start at the top, we're adding 3 plus 2, which is 5, 5 plus 9, 14, 14 plus 13, 27, right? Which means 21 and 20, well, 20 and 21 will both fall into this category, right? Because we were only till number 14 here. When we added that 13, we ended up at 27, which means 20 and 21 is here, which means your median is going to be basically the midpoint of this class right here. And what was this number? 68.5 to 75.5? 72? Yeah, so that means your median is going to end up being 72, which you can see with respect to our mean calculation, we're not really that far off. In this case, we're pretty good. And you know, obviously you can do that same calculation if you start adding up from the bottom. So if we add from the bottom, you've got 3 plus 2 again, which is 5, 5 plus 8, 13, and then again 13 plus 13 puts you at 26, right? Which means again your number 20 and 21 position is again back in the same class. So you're going to be at a median of 72, the midpoint. So I'm not sure why your textbook does not ask you to calculate medians or, well, I guess you can do the mid-range if you want to in this. But so this is basically the idea is use that position formula, find out what the position of your median has to be, and then start, like I said, adding up that frequency column and see where those positions will fall under which class, and then the midpoint for that class ends up becoming your median. So I kind of wish your textbook talked about it, but they don't for some reason, which is really a shame. Okay, questions on mean or median so far? Simple calculations, right? Just got to remember, obviously, which symbol to use if you're looking at a sample or population. Now, our third calculation for measure of central tendency is mode, so the value that occurs most often in a data set. No calculations involved here. You're literally trying to figure out which value has the highest frequency if you're doing this as a frequency distribution. So you can do this for grouped data. You can do this for individual data values, like we're looking at number 1 as our example. So now here's the thing with mode. You can have just one mode, which is what we call as unimodal, but sometimes you can have more than one data value that occurs most often. So you will see right here, we're talking about if you have two data values that have the same highest frequency, you can actually have a bimodal data set, which means you'll have two modes in that data set. And depending on, again, what data set you're looking at, you can have a multimodal data set also. So you can actually have more than two. Some textbooks will differentiate into trimodal and then get on, but here we're talking about unimodal, bimodal, or multimodal or multimodal. So you can have those, or you can have a data set where each data is occurring the same number of times. So they could be just one occurrence or two occurrences of each. So you could actually end up with a data set that has no mode at all. So in that case, you would say no mode. You will not say zero, because technically zero is still a number. So when you're saying the mode is zero, that means you're saying the number zero occurs the most times in our data set. So don't say zero mode, just say no mode, okay? Because those are two different things here. So again, looking at this example here, we're looking at number of public libraries in a sample of 8 states. So how many libraries these states have? So again, you can see they're arranging it in order from the lowest to the highest. That is really helpful. But if you don't want to do that, and if you have a relatively small data set, then it's easy for you to figure out which is my highest occurring data value, which in this case, of course, it looks like it's 77, which has an occurrence of 2, and the others are just occurring 1 time. But if you had, again, a large data set, it would probably make more sense to try and put it in order, or you can even try and do like a tally kind of thing just to see which has the highest frequency. This example here shows the number of licensed nuclear reactors in the US for a recent 15-year period. And again here, you can arrange it in order, which it looks like they've actually already given us in that format. And we've got 104, which occurs, well, no, the bottom row is not in order, is it? So 104, that occurs 5 times, and looks like 109 actually also occurs 5 times, right? So you've got a bimodal with 104 and 109. So going back to our, I think this is an example of no mode in this case for number 8, because you've got each of them occurring once. So for example, 8, there's no mode. As far as the modal class goes, that's basically finding the mode for a grouped data set. So in this case, of course, you're looking at your frequency column and seeing which one has the highest frequency. But you can see again the salaries for our top CEOs between 15.5 to 20.5. I'm guessing this is in millions of dollars, is where you have 13 of these CEOs. So that's going to be your modal class, because that's with the highest frequency. So let's do this guy first, since I'm already at number 13. What will be our modal class here? Yeah, because that's the one that has 13 as our highest frequency, right? So that means your, whoa, modal class for this guy is going to be 68.5 to, what was that other number? 75.5, thank you. And then for number 1, you guys have already put this in order when we did the median, so you can use that to try and see what your mode for number 1 will be. Is it unimodal, bimodal, multimodal, or no mode? Okay, what are we looking at as our multi?
5102.
Yeah, because you've got 50, which has an occurrence of 2, 95, 102, and 160. Okay, so our mode in this case would be 50, 95, 102, and 160. Multimodal, right? Okay, any questions on that? So like I said, mode really does not have a calculation. You're just looking at which has the highest frequency that occurs. So they're talking about the mode is the only measure of your central tendency that can be used in finding the most typical case. And this is, again, kind of ties into what Michael, you were talking about before. So, you know, a lot of times, and, you know, we looked at those examples at the beginning of this section where they were talking about the average American does this, or the average American's height is this. So, can't remember, I think it was NPR. They actually did a study. Well, these two gentlemen did a study because they wanted to know what a typical American actually looks like. What would we say is a typical American? So they actually did a study nationwide. And the surprising part is the average American that we think about is not what the study found. So just from your perspective, who do you think is the average American in your mind? Well, obviously we know the average height is 5 feet 9 inches, right? They told us that for men, and let's not forget 3.6 inches for women. But other than that, what do you think? What's your mind thinking, okay, this should be average American. Am I average American or am I not an average American? Do I fall into that category, or, I mean, whatever you think. What do you think an average American should be?
I don't know.
You don't know?
America's pretty diverse.
Okay.
Pretty big.
Okay. I mean, you know, and it doesn't necessarily have to be in terms of ethnicity or race, but more in terms of what do you think, would this person be employed? Would this person be, I don't know, we've already talked about, I guess, what their body type would be, or just whatever comes to mind. What do you think of a typical American? And, you know, I think even if you talked about in terms of race or ethnicity, what is our majority population still in the US? I mean, we are diverse, but again, where is our majority lie? So just thinking of all of those things, what do you think a typical American would look like? Would it be a male or a female? Male, okay.
40.
About 40, okay. What do you think average income would be for a person about that age, that type? 55,000 a year, okay. Any idea what industry they might be in? Like what work Industry? Manual labor, okay. Sorry? In an office? Okay. Would they be 5'9"? Would they be taller than that?
I got 6 feet.
You got 6 feet? Okay. 5'7"? Okay. Married, unmarried, kids?
Married, family.
With family? Family as in dogs and cats or
Family
kids?
is got kids and a dog.
And a dog?
Golden
Okay.
retriever.
That's very interesting.
Kitty boy.
Anybody else think outside of what we've gotten answers so far? It's good to the young people because if I had asked this to an older group of class, they would have said baby boomers. No, honestly, because think about what happened after World War II. People were popping out babies like there's no other thing they had to do. I mean, literally, that's why they're called the baby boomer generation, right? Because there was a boom of babies happening after World War II. Because, excuse me, right now, that's actually your majority population is these retiring, getting close to retirement folks at that age. But guess what? They are also not your typical American based on this study. So the study found that the most typical American is a child, aged 5 or 6 years old. I guess in grade school, whatever that age is. I don't know. I don't have kids, so I don't really know. I guess they're in first grade or ish. Yeah, I don't know, somewhere in there. But that doesn't really help the purpose of the study, so they had to take the kids out. Like, sorry, you cannot be our average American. So if you're interested in finding, I have a link somewhere. Where do I have that link? You know what? I'll post it in D2L of who they found out was your average American. Okay, so if you're interested, go listen to that podcast. It's really interesting. It's not very long. I think it's about half an hour, and you can find out who that average American is. Alrighty. So since we can't really have kids as the average American, the poor kids got kicked out of that study. All right, let's look at this guy here. Again, it's a frequency distribution, but this is a categorical distribution, right? It's not grouped data. So you've got the number of gallons of various non-alcoholic drinks Americans consume in a year. We've got soft drinks at 52, water at 34, milk at 26, and coffee at 21. So of course, what would be our most typical? Soft drinks, yeah, soda at 52 gallons consumed. So again, you can kind of see here that your mode doesn't really just have to be based out of numerical categories, right? It can definitely be this most typical case. What's the drink people are mostly drinking in this case? And apparently, as much coffee as Americans drink, that was at the bottom of that spectrum, right? I mean, so soft drinks have definitely done our coffee drinks here. This is kind of where we're getting into the discussion what Phil was talking about in terms of what if you have this really large number, an outlier that changes our study. So in this example, we're talking about, you know, what happens when you have this outlier. Now, your outlier can be a really large number, or it can actually also be a really small number, which is not representative of your data. It's kind of really far away. So this example is kind of neat. And this is kind of what I was getting at is we have a small company here that consists of the owner, the manager, the salesperson, and 2 technicians, and their salaries are listed over here. And we're assuming this is the entire population, right? Because we're just looking at this one company. So again, you'll notice we're using mu instead of X bar. And if I try to calculate their mean, I'm taking all 5 of these salaries, adding them up together, and that shows me a mean of $40,000. Now look at this data set here. Does 40,000 really represent what most of the employees at this company are making? No, 3 of your employees are far below that 40,000 mark, right? Just the manager is at the 40,000, but then you've got the salesperson and technicians at 24 and 18,000. So what's happening is that $100,000, which is the owner's salary, is really pulling your data towards the higher value, and it's moving you towards 40,000. Now, if we did a median calculation here, where would our median be at? $24,000. So with the median, yeah, you're kind of in the neighborhood of these guys, but then of course it does not really represent your owner in that case. If we went with mode, what would the mode be for this data? The 18, because we've got 2 technicians at that 18,000 mark. So then again, you kind of have to think about, if we say average can be 40,000, which was coming from the mean, average can be 24,000, which is the median, and average can be 18,000, which is our mode. They're all averages, but now they're looking at 3 completely different values. So you have to decide, okay, if I'm the researcher, which one seems more accurate and more representative of my data, and which one seems that it would be, I guess, misleading in a way. Even though mathematically it's accurate, does it really represent the company, right? So that's what we're talking about, and then we'll get into mid-range next time, okay? So just kind of look through this. I'll open up your homework for chapter 3, and I will bring your exam back on Monday, okay? All right, guys, have a wonderful weekend.